All right. So let's go ahead and get started. By now, you should have seen the list of everything that's going to be on the exam. You should have watched the makeup video for the class we missed. You should have questions. Now would be a good time to ask them. Ready, go. Yes? Okay, so the question is, what's the difference between a do loop and a while loop? The difference is that in a while loop, the check to see whether you execute the body of the loop happens before you enter the loop, and the do loop, the check happens after. So a do loop will always execute at least one time, always, regardless of anything. Okay? And that's useful sometimes, because sometimes you want the loop to execute once, and so you can just kind of invert it. And then, yes?
When you were going over vectors, you said you can tell the vector how many numbers to expect. If you tell it how many and then there's more than that in like whatever it's getting numbers from,
Yes.
will it only take that?
Okay, so the question is about vectors. One of the things you can do is you can assign it an initial size to tell it how big to make itself to hold numbers. And the question is, what happens if you try to put more stuff in there? And the answer is, it depends. If you try to put more stuff in there by using the square brackets that says put it in this slot, and the slot number is higher than you've actually told it, the program will crash. And the program will say, I don't know what you're talking about, there's no space like that. If you've told it to be a certain size, and you add things to it using pushback, the vector will grow bigger, and it'll resize to hold as many things as you like. So that is your answer. It depends on how you're trying to put things in there. Yes? So the question is, can you only add values to the end of vectors? And the answer is it's easiest to add them at the end. I don't know in the vector class, we'd have to look in C++. Some languages have a thing where you can put it at the beginning. But here's the problem, right? Most of the time, we have a bunch of memory boxes, and we say, hold 5 memory boxes, right? It's easy to find place at the end. It's hard to put one above because there might other be things in memory. So if you want to put things above, most of the time you have to move all the other stuff down. Does that sort of make sense? So most of the time it's easiest to add it at the end. Though there's a lot of magic that's going on in vectors that you can't see. So, yes, sir? Yeah, so the question was, can I elaborate on cn.ignore? So cn.ignore is just a way for you to get junky stuff out of your input stream, right? So if the user is typing things along and they hit return, sometimes that return they hit will be in your input stream. And you want to get rid of it because, say the next thing you're going to read is an integer, right? Can an integer hold the value return? Right, it can't. So this is sort of a bad example because return is not the best thing for this. But cn.ignore is for when things get put into your input stream that like break the input. Like, for example, you have a decimal point that's going into an int, and it's going to break cn. You can say cn.ignore, and it will get rid of that decimal point or that thing. And you can do it in cn.clear, which will enter everything that's waiting to be put in. Does that make sense? So you can kind of use that to clear out bad input that you know has broken things or is about to break something. Yeah? Yes, it will be a handwritten exam. I mean, your part will be handwritten and my part will be typed. You wouldn't want to read my handwriting for the exam. Yeah, and I'm actually testing out some new technology this semester. The autograder is one of the new technologies we're testing. I'm going to test a new technology for grading. It's a product called GradeScope. And what will happen is I will hand out to you in class PDF exams, and there'll be little boxes where you have to like write your answer. There'll be workspace, but you have to write your answer in the box. Then what I'm going to do is I'm going to take all your exams and I'm going to chop the staples off with a big paper chopper, and I'm going to feed them into a printer that's going to scan them all into one giant PDF file. And then I'm going to upload it to the website, and the website is going to have copies of all your stuff, and it will help me grade. I can grade all your stuff online, like your exam online, and the theory is it will help me do things faster because it will look at all your answers and it will find everybody who had the same answer and put them all together. And then I can say everybody who answered 2 here when the thing was 3, I can just say, hey, you all missed this. And so instead of having to look at 51 individual exams, I can look at the problems individually and just look at the answers. So it makes my job easier. And then when you get your exam back, you'll get it back through Gradescope. Okay? You'll be able to see it online. Well, you'll fail. That's okay. We'll all do our best. I mean, it scans it. I will look at it. If the computer can't read it, I will read it. So, but I'm just trying to. The computer is dumb but fast, right? So let's let it do the dumb things fast, and I'll do the smart things slowly. The sort of smart things slowly. Yeah. Uh-huh. Yeah, in this class, you'll probably only ever need to use them together. And the idea is if somebody types something in, like say it'll become a little clearer. Right now, we're only taking input and running the program out. Now that we have more loops, when we're running, we'll be taking input from people and like asking for more input and input. And if people put the wrong thing in and you know you're going to loop again and like read something else, you want to clear it out. Honestly, it's not a huge deal. So, yes? Okay, so the question was, are function prototypes declared outside of main or with all the variables inside main? They're declared above main, outside main. Essentially between where all the pound define, pound include, using namespace standard, and then you have your function prototypes, and then you have int main. So they're before int main. Okay. Yeah, for this class. You can do other stuff later. C++ is a very complex language. There are many, many things you can do. Other questions? Yeah. Okay, so the question is, are there going to be questions on the exam where you have to figure out what happens if somebody puts a wrong thing into CN? The answer is almost certainly. After this, after the question and answer period, I have this big stack of practice questions here. I think I have 7 practice questions for you. I should have 8. I'm going to have to put one up on the board. I forgot to make one for 4 loops. And then that's what we're going to spend the whole time doing, is just going over these practice questions. And a number of them are about CN. So, yes. One thing about the exam, I'm not going to, in my mind, I'm not going to do anything to trick you. Right? You know everything that's on there. I gave you a list of everything that's on there. You've used almost all of it for the projects. For vectors and for the functions, I won't make it incredibly complicated, okay? Just so you understand the basic functionality. I'm not going to try and trick you, right? The language is tricky enough that I will write problems that use the language in the right way to allow you to demonstrate your knowledge. But it's not going to be like, I'm going to give you all this code and there's going to be 1 semicolon missing and you're going to be like, fill it all out, and then I'll be like, haha, you missed a semicolon, it didn't compile, you fail, right? I'm not going to do that today, ever, today. Tomorrow, I mean Wednesday. So you can assume all the code works correctly. You can assume that what you got to do is find, where do we start? Hit main and just start chugging through, okay? You might have to write a little code yourself too. Yep. Is there going to be what? Are there going to be multiple choice questions? Absolutely not. In fact, you don't want my multiple choice questions. Yeah. Yes, there is partial credit, of course.
So you talked about starting at int main, right? But
yep.
If there is like or the code where it's like a function, where it's outside of int main, right?
So the question is, if there are functions and they're above int main, where do you start? The program execution always starts at int main. The function prototypes are before int main, because the compiler requires that in order to compile the program, but they don't affect where you start running the program. Okay. Do you have a question? Will you have to draw flowcharts using shapes? It's entirely possible. Is that one of the topics that was listed on the sheet? All right, there's like 4 shapes. There's like a square oval, a diamond, a box, and a parallelogram, and a box that has 2 little lines in for so. I think I've got a 6-year-old, and I'm pretty sure he can handle that. So, will I make you do that? I don't know. I might now that you brought it up. So, yeah. I haven't written the exam yet. So, yes. You might sometimes, yeah. Well, which ones do we know? IOStream, IOManip, FStream, math, vector. There's only like 5, right? String, sorry, 6. So there's not that many. The question was, do you have to, if you're writing code, do you have to put the proper pound includes at the top? And I was thinking, yes, that would be a reasonable expectation. So. Yeah?
I didn't understand when and why you would use output files.
So the question is, when and why would you use output files? So let's say that we were running a program, and we were, say, doing an epidemiological study, and we had enrolled 100,000 people. And we wanted to get a list of all the 100,000 people who had high enough eligibility scores to be in the project. How many people do you think that might be? Tens of thousands, probably. So if we print tens of thousands of things to the screen, is that useful for the user? Not really, because it's just like stuff scrolling by and scrolling by. So sometimes we want to output to a file. And very often we want to output to a file because that file is going to be input for something else later. It puts it into the file, absolutely. It never appears on the screen. So if we're doing like OFStream with an output file, and we do put things in the output file, that output will never appear on the screen. It just doesn't unless you do cout. It only goes into the file, and then later you have to look in the file and see what's there to find out what your program did. Yes, sir?
When you're reading from a file and outputting to a file, you're basically copying stuff from the old file to the new.
So the question is, when you're reading from an input file and outputting to an output file, you're basically copying the stuff between. Depends what your program's doing in between, right? It's not necessarily copying. The example I gave you was essentially copying. But your program can read in data. It can do whatever it wants to that data using an algorithm, and it can output to a file anything it wants, whether or not it's related to the algorithm, the data that got input, right? So the example was like, I think we just reversed the order or something, right? That's like a simple example. But in terms of outputting to a file, you can output anything your heart desires. That's expressible by computer. So. Yes, sir? Yes, so the question was, we've seen 2 different ways of casting a variable. The C style, where you just put the type in parentheses before it, and the C++ style, where we say static cast underscore angle brackets, or right? Static underscore cast angle brackets with a type. You should recognize both. Which one should you use? You should generally use the C++ one. So most people, when they write C++ code, they sort of write like C+ code. They sort of write in between. But we're trying to encourage you to write pure C++. Anything else? All right, well, I think that was 17 seconds. So I have 2 handouts for you. One is a single sheet that I printed some time ago, but didn't have time to give you. And then the other is like a stapled sheet that's got a bunch of things. You should get a copy of each. And then what we'll do is we will just start doing the partner-assisted exercises. You'll do these together. We'll talk through the answers on the board. You can, ones we don't get to, you can take home and work on. Trying to remember to post these on Blackboard. How many of y'all like Canvas better than Blackboard? Yeah, sorry about that. I never used Canvas. I looked at it the other day and it's way better, but we already have everything on Blackboard. So if you fail this class and want to take it again with me sometime, I'll use Canvas next time. Wait, I need one, sorry. Let me have one. All right, so once we get these things handed out, turn around, find a partner. Do you remember we haven't done these very much? One of the things about this class, have you all noticed that this class is on Monday and Wednesdays? Mondays and Wednesdays is a bad schedule for 051 because we actually lost a day of class that we pick up or not pick up later in the semester. So I feel like we're like 1 day behind where we should be. So normally I do more of these in class. It's just we've been rushing a little bit because we're sort of behind a little bit. So find someone to work with, turn around, face them. This is not a silent thing. Do you remember? Do we need to remember this? How do we do this? Read the problem out loud. One person solves, one person answers. I'll tell you what, let's do the string one first. The string one first. It says string functions. Sorry, I forgot this part. Okay, so we started in at main. We found the string fake that had a whole bunch of numbers in it to help you see which number was in which place, not just to confuse you. It was to help you. Okay. Now that I have set you up with this, what I can do on the midterm is I can delete the 0, and everybody will be off by 1. All right, but if I put those numbers there, you can check. You can make sure I'm not screwing with you. What should they start with? And then you can use them to see where things are, okay? So I do this to help you out. All right, so the next string is ejecta frowns upon. We have a couple of temp strings, and then we int an integer leng. What does that initialize to? Nothing. So what's in there? We have no idea. Could be anything, right? Okay, so we define len as the length of the string in. How long is that string? 18. How did you know that? You counted? Really? I just went here and I said, oh, 10, 17, but there must be one more because we start numbering at 0, so there's 18. Okay. If I don't give you this on the exam, you should just go through and write them. Okay? Seriously, just do that. Okay. So out equals in.at length minus 3. What do we do for that? Uh-huh. So length is 18. 18 minus 3 is 15. So we can go, if we look underneath this 5, which is the 15th place, what letter do we find? P, as in pizza. Okay, so out is equal to P. Now what? Okay, so P is going to be equal to out, which we knew was P, plus, what does plus do with a string? Mashes it together. In computer science, we have a very fancy term for mashing things together. It is called concatenate. You can concatenate things together, which means you mash them together. So then we say in substring 8, comma 2. What does 8 and 2 mean? Uh-huh. So it's the 8th place in the string, which we can find because it's underneath the 8. And we take 2 letters. We have RO. And then we take in substring 1 to 4. So 1 to 4 is what? JECT. Okay? So after this line, if we were to output what out was, what would out be so far? Project. Okay, we go into the next line. Out is project, and we're going to add in at 6. What thing is at 6? A space, and we're going to add a substring 16, comma 2, which is on 16th place under the 6 towards the end, O and N. Okay, so now we have project space on. Next line, project space on plus in dot at length minus length. What's length minus length? Even if length is 18? How about if it was 19? Yeah, it's always going to be 0, right? So, okay, so this one's going to be 0, which would be E, project space O-N-E, plus in at 13, another space. Okay, so we have project 1 followed by a space. This line, out at, yeah, sorry, I was going to put a couple of comments here. Sorry, just, I forgot what I was doing because I was too excited to talk. Okay. So what I was going to do is I was going to say, make the font match. Okay, so out back here was what? And then out on the next line was on with a space. I'm just going to indicate a space with an underscore. And then next one, we now have project O-N-E space, right? Okay. And how do we get WAS? Oh, we use this, didn't we use this space before already? Right, we had in at 13 here. Can we use it again like that? Yeah, absolutely, right? It's just copying it. It's not like it's rearranging it. This string in is staying totally the same all the way through. The fact that we are using ins and substrings is copying things out. It's not changing the original string. Okay? And then down here, oops. What do we have? Okay. And then we output that. Then what we output is project 1 was fun. Okay. All right. Everybody good with that? Any questions? All right. So we have this other thing, this other packet, which I realized I made a horrible printing mistake when I was creating it, rushing out of my office. And you will notice that there are actually multiple copies of the same thing, some of which are old versions from years ago. So these are going to be baffling. What I'm going to do is when I go back to my office, I will post the correct one on Faceboard, Blackboard, right? And then you will know. But I'm going to tell you which ones to do right now. So turn it upside down. So the tracing the functions is on the back because it printed backwards. And you can do, I'm going to do the hard ones first, okay? Instead of the easy ones. Are you good with that? So find the one that says a program to annoy people. It doesn't actually have a title on it, but it says find the results of the program, one person using I equals 2, j equals 9, the other person I equals 20, j equals 14. Okay? Looks like this. Have fun. When you're both done, like wave at me or something so I know. Okay? Yeah, sure. Oh, yes, thank you for reminding me. You can have a whole bunch of Oreos. Here, open your mouth. Good catch. We should pick it up so nobody steps on it. Start the recording again. Hi, joining on the video. Sorry, we did some stuff. Okay, we were just arguing about that. So the net effect of this line, j plus 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 I, is that I becomes 3. The computer calculated 12, but it doesn't save it. So no, I plus plus, this plus plus operator has implicitly in it an I equals. It implicitly has it. The increment and decrement operator automatically change that variable. Yes?
How would it change if it was j plus I plus plus?
The net effect would be the same, but the number it calculated would be 11 instead of 12.
So it would have said 9 plus 2 and then increase I 1.
Exactly. Yeah. This stuff is really tricky. It's great for exam questions. Okay? Which is why I wanted to step through it. Okay? Everybody see what happens there? All right. Now we get j equals I plus j. What happens? Great. All right. Now, if j percent I equals 0, what is that percent sign? Exactly. What is the remainder of j divided by I? So what's the remainder of j divided by I? There is not, because j divided by I is 4. It goes in evenly, so the remainder is 0. So at this point, which way do we go? Do we do the if or the else? Okay, so here we are. K equals I divided by j. Okay. Great. So this is 3. This is 12. What's K? Yes, sir. It is integer division. We're dividing two integers. Dividing two integers. So, if you divide two integers and it ends out being 3, it ends up being a quarter, what happens to the decimal part? It goes away, it gets cut off. See, this is how I'm going to get you all in the exam with stuff like this. Yep. Yes, if we had cast either I or J to a float, it would have been floating point division. But an int over an int, this is really annoying, right? Because not only you can just look at it and go, oh, it's division, but you actually have to go I and J and go back and look at what types they were and make sure the type's right. So total tricky thing. Don't worry, like did you hear half the class go, oh? Like everybody, yes. No, if you cast it, you're not changing it permanently. Nope. It's 0 because the decimal point gets lost. Like if for some reason I had been 11 and it was 11 over 12, the answer would be 0. Because when you do floating, the decimals just get cut off. Absolutely. So if the answer is below 1, it will be 0. If it's between 1 and 2, it will be 1. It just chops all the decimal points off. Okay. All right. So what do we output here? Yep. Then where do we go? Yeah, it skips the else statement, returns 0. We're done. Okay. All right. Everybody good with that? Oh, sorry. They kind of turn in the air like that. So, all right. Thank you very much. Okay, who wants to do the next one? Someone else want to do the other one? Go ahead. All right. I'm gonna redo this. This is I equals 2j equals 9. I'm going to create another little table over here. Okay. And this one is for I equals 20, j equals 14. Uh-huh. And what's their values? We don't know. Uh-huh. And what's in K? And L? Okay. Everybody good with this so far? All right.
And then we compute, but we don't store it in anything. So j is 14, and you add 21 to it, so that becomes 35.
So we calculate the number 35, but we don't save it anywhere. But I becomes 15. Yes.
Actually, I becomes 21.
Oh, sorry. That was J. Sorry, I was looking at the wrong number.
And then j stays 14.
Yep.
And then we're reassigning j as j equals I plus j. So j is 14, and then I is 21, so that j becomes 35.
Yep.
We still don't know k and l.
Nope.
If the remainder of j divided by I is 0, so j divided by I would be...
Okay, if the remainder of j divided by I is 0, and we're dividing what, 35 by 21? That's clearly 0, right? No, it's not. Okay.
So we're going to get a float value, but since it's not 0, so we go to else.
Yep.
L equals j. So j was 35, and now we make L as 35 too. And k becomes I divided by L. So I was 21.
Sorry. Yes, I'm trying to type and format at the same time. Okay. So we 21, 5. All right, what's 21 divided by 35?
0. No, it's not 0. It's a float number. It's
0.6. Yep.
and then we see a.
Pardon? No! No, you can't leave it as a fraction. The computer is not going to leave it as a fraction. Have we talked about anything in this class that leaves things as a fraction? You get integers or you get decimals. Come on, it's a factor. Everything's a factor of 7 here. You should be able to look at sevens, right? 21 is 3 sevens, 35 is 5 sevens, right? So, all right. Good. Thank you. Cookies or candy, which would you prefer? Ooh. That's a better one. Okay. All right, the next one we should do is towards the back. It says vector operation. Let's do vector operation. Yeah, okay. Sorry about that. So I grabbed an old problem, and there's different ways of doing the same thing. Okay? This construction, ifstream data file with the name of the data file in there, is exactly the same as ifstream open. Okay? Yeah, it's just that this is a string literal. So we're able to say this is the only file I want you to open. If you wanted, you could also do, input file name and then put the file name cstring there. You could do it that way. Okay, so it's just another way of doing the same thing. Okay, so we open the data file, assume the data file's there. Then what do we do in this next thing? Exactly, it's making sure that when we went out to open the file, that it actually was there and opened and everything happened successfully. Yes? Data file is the name of the variable that we created right there. So just like we created, I just used the variable name data file. Just like we used OMG for an int and Roxor for an int, I said ifstream data file. It is not a special word in any sense. It's just a variable name that I chose so that, yes, it does exactly the same thing as open. Okay, so we open the data file, and if it doesn't open, what happens? We return 0. We just program exit because it couldn't find the data file. Okay? All right, now we have this line. What does the next line do? Mm-hmm. Yes, so while there is a value, what's going to happen is we're going to read that value out of data file and put it into what variable? OMG. So OMG is going to take on a value, and then what is it going to do with that value? Adds it to the vector. So let's step through this then and see what happens, okay? So what is the first number that gets read out of there? Okay, so we read a 1, right? Just like this. So at the first line, the vector is empty. OMG is 1. We still don't have any idea what Roxor is, but the next line we do pushback. And what happens is that 1 we had before gets added to the end, okay? Just like that. Everybody with me? Okay, what's the next value we read? Now, I'm going a little bit out of alignment here, right? Because as you can see, we can't easily just line everything up. But what I'm going to do is I'm going to step through it so you can see what's going on, and we'll make a nice, neat version. Okay, so we read the 3, and then we add 3 to the end, right? Everybody with me so far? So this time right here, I'm going to put some comments here. Okay, what happens next? We read a 5, like that. And then what happens to that 5? Add it to the end. Okay, everybody see how this is working out here? Okay. So, do we need to keep stepping through, or can we predict what's going to be in the vector at the end? Which one do you think? How many of you feel we need to step through? How many think you can predict what's happening at the end? I think it's safe to predict, right? Because this is a very simple loop. Nothing weird is happening. So at the end, what we should have is 1, 3, 5, 7, 9, 11, 13, 21. And then then OMG will be 21 because that's the last thing we read in. We still don't know what Roxor is, okay? And this is at end of loop. So now we have a whole bunch of values in there. We might have to keep track of what was in here. We might not ever use it again. So everybody good with that? Questions? All right. Then now where do we go? We go to C error. By the way, C error is just like C out, except it's for outputting error messages. Oh yeah, sorry, I skipped a line. Thank you. Yep, so now we have to set Roxor equals, what does it equal? What is that? I think it's 8, too, yes. This is where we set Roxor. Okay, now what? Okay. Yep. Okay, now we have this for loop. I'm glad. I thought I had forgotten to put a for loop in the practice problems. But what do we do with this for loop? Yep. Uh-huh. Okay, so this loop starts at I equals Roxor, which is 8, which is kind of the size of the vector. We stop when we keep going as long as I is greater than or equal to 1. So we stop when I equals what? 0. We keep going if I is greater or equal to 1. We stop when it's 0 if we're going down. And each time I minus minus means I gets smaller by 1 every step. Okay? So the first time through, we have I equals 8, I greater than or equal to 1, I plus plus. So if I is 8 greater than or equal to 1? How many of you think yes? How many of you think no? How many are not sure? 1 is generally greater than 8, so we actually do the loop. And what we output is 8, angle, angle, space, angle, angle, WTF 8 minus 1. What?
So the minus minus doesn't take the immediate effect?
No. The I minus minus happens after everything else happens. Okay? So I is 8, 8 is greater than or equal to 1, so we execute the body, C out 8, angle, angle, space, angle, angle, WTF 8 minus 1, which is, what's in the 7th place of this vector? Right, because we go 0, 1, 2, 3, 4, 5, 6, 7, so the first thing that gets output is 21. Okay? Then the I minus, when you reach this curly bracket at the bottom, the minus minus happens. So I is now, great. Is 7 greater than or equal to 1? Generally, yes. So we go into the loop again, we print out 7, and WTF 7 minus 1, which is, what's in the 6th place? 0, 1, 2, 3, 4, 5, 6, 13, so we'll output 13. Okay? Everybody see how this loop goes? Then it decrements 1, it becomes 6, we output it. So I'm just going to show you, I have the code here, we will run it and verify that that's what actually happens. This is the code, and when I run it, oops, wait, where was I running that? Right here. It prints out Roxor, and then it prints everything out essentially in the reverse order. Okay? Yes, sir? Yes? All right, so you don't need to know this for the exam. This was just a typo I left in there. There is C out, which does output. There is C error, which does output. You can tell them apart outside the program through some tricks, but they will both appear on the screen. When I am programming in this class, I normally use C error when I'm doing scaffolding, like when I want to output some stuff in the middle so I can see what it is. And then it makes it easy for me to go back later and just take out all the C errors. I don't have to figure out which thing I'm trying to keep and I'm trying to get rid of. So, yes, sir. Oh yeah, I probably have the wrong data file. I suspect that when I typed my data file in, I did it wrong. Oh yeah, sorry. See. Here, I'll put a 9 in, and then that'll be right. Sorry. Better? Were you all just sitting there in horror the whole time and not saying anything? Why don't you say something? There's candy involved. Here you go. Trying to find a heavy one because. All right. Cookie, anyone? Behind you, okay? Don't steal it. Oh, no. No, that one got away from me. All right. All right, so we can really quickly do one more. I want to do the function one really fast. I'll tell you what, we'll just do this on the screen because I didn't leave much time. Sorry about that. Too much time spent throwing cookies. Just give me 1 second and I'm going to grab the code to make sure I have the right thing. Okay, so we're looking at the tracing functions problem. And you'll see we have, the right stuff at the top. We have pound include IOStream. We have using namespace standard, and we have these function prototypes. Just for ease of being able to see the code at once, though, I'm hiding that. So, Okay, so here's our code. Where do we start? Are you sure? Okay, so we start at int main. We go through and we declare 3 variables. We declare variable x, we declare variable y, and we declare variable z. Okay? And what is x set to initially? 12, y is 8, and z is 0. So, because we were good. Okay. Pardon? Oh, because I used a comma right here instead of a semicolon. So I just put some white space in there. I did it like that. Does that help? The different ways of doing the same thing. Okay. We're setting z equal to something. What is z getting set equal to? What? Why is z? Oh, sorry. Yes, we set z equal to 0, and then down below, after we set it 0, we set it to something else. And what is it getting set to? Grumpy of what? What is x plus y? 20. Where does that 20 go? Down here. So what happens is down here, parm is now 20 because that's what we passed in, right? We did x plus y. We made that 20. We put it into grumpy, and so grumpy down here gets that value 20. Okay? So is 20 mod 2 equal to 0? It is. So what are we going to return? Cat of parm. What is cat? A function down here. So down here we have what? Parm? And what is parm? Is this the same parm down here as it is up there? Why not? Okay. Even though, sorry, I deleted this, didn't I? Even though they both have a parameter and I use the same name parm for both, they are different ones. They only exist inside their respective functions. So parm 20 here says, is it 20? Yes. And then we do the if part instead of the else part. We call down here, we get parm of 20. So what do we return? 20 plus 6 is? Are you sure? For most values of 20 or all of them? Okay. So we return 26. Where does that 26 go? Back into z? No, it doesn't. It goes back here to grumpy. So what we said is we said return cat parm. Cat parm we figured out is 26. So this returns 26. This whole thing returns 26. So cat parm right there becomes what value? And then we return it. And where does that go? Back to z. So grumpy x plus y becomes 26. Z becomes 26, and we output 26. Now, if this is confusing to you, and it might be, here's what I recommend. You can do something like this, and I'll use Sierra, right? And you can put in some print statements to kind of trace which way your code is going. And things like that. So if you put output statements, even though there's multiple functions, you can kind of trace the code through. So I will put this code online. I recommend you do this over the weekend or over the Tuesday. I will see you on Thursday, Wednesday. I'll see you for the midterm. Have a good Tuesday. I'll have my office hours. You can email me stuff. Bye.